A dipole is defined as two charges of equal magnitude separated by a short distance. So, if we have a charge plus q and another charge of same magnitude but opposite sign minus q separated by a small distance 2a is known as a dipole. And the characteristics that defines a dipole is known as the dipole moment. Dipole moment is defined as P is equal to 2AQ. Here, 2A is the distance or separation between the charges and Q is the magnitude of the charge. Dipole moment P is equal to 2AQ. So we know that the charges are plus Q and minus Q. So definitely these charges are producing an electric field. So now let us discuss about the electric field produced by these charges. When we consider the electric field due to dipole, we have two cases. That means the point can be somewhere on the axial line of the dipole. Somewhere it can be here. So electric field due to plus Q will be there. Electric field due to minus Q will be there. So first what we have to do, we have to calculate electric field due to plus Q on P and we have to calculate electric field due to minus Q on P. We know the direction of the dipole moment is always from minus Q to Q. So if we write the electric field due to plus Q, let us denote it as E plus Q is equal to 1 by 4 pi epsilon 0 Q divided by the distance. Okay, so what is the distance? Distance from the midpoint of the dipole or the center of the dipole to plus Q is A. And if we take the distance between the point P to the center of the dipole as R, we can write the distance from plus Q to P as R minus A. So it will be R minus A whole square. And what will be the electric field due to minus Q? Yes, it will be E minus Q is equal to 1 by 4 pi epsilon 0 Q divided by what will be the distance? Yes, from the center of the dipole to point P, it will be R plus A. Yes, so the distance will be R plus A the whole square. But we know the direction of electric field at P due to Q and due to minus Q are opposite in direction. So we can denote it with minus of 1 by 4 pi epsilon 0 Q divided by R plus A the whole square. This minus sign indicates the direction of electric field is different, but the magnitude changes by a factor of r minus a square and r plus a square only. So what will be the total electric field at P? We know electric field follows the superposition principle. So the total electric field at point P, E will be equal to electric field due to plus Q plus electric field due to minus Q. So let us write the expressions. It will be 1 by 4 pi epsilon 0 Q divided by R minus A square plus of minus. Since this minus sign is there, we can write instead of addition, we have to write minus sign. Okay. 1 by 4 pi epsilon 0 Q divided by R plus A square. So just look into this equation. We can see that the factors 1 by 4 pi epsilon 0 Q is common in both sides of this minus sign. So we can take those quantities outside the bracket. So we can rewrite this equation as E is equal to 1 Q divided by 4 pi epsilon 0, and inside the bracket you can write 1 by r minus a square minus 1 by r plus a the whole square. So definitely we need to simplify what is inside the bracket. So we need to perform the cross multiplication. So when you cross multiply, your equation will become electric field E is equal to Q divided by 4 pi epsilon 0. In the bracket, if you take this r plus a square to this side, r minus a square to this side, r plus a square is r square plus 2ar plus a square. Okay, so minus sign is there. I'm writing that minus sign there, and r minus a the whole square will be r square minus 2ar plus a square, and in the denominator we can write r minus a square. So r minus a square we can rewrite as r minus a into r minus a. Okay, and same like r plus a the whole square, you can write it as r plus a into r plus a. Okay, so let us resolve equation once again. Q divided by 4 pi epsilon 0. See here, there is a bracket here. So if you open that, this is r square, this is minus of r square, so plus r square minus r square, they will cancel out. So r square and r square get cancelled. Here it is 2ar and this is minus of minus 2ar, so minus of minus 2ar is plus 2ar, so they will add up. So in the denominator you will get 4ar, 2ar plus 2ar, that is 4ar. And come back to the denominator once again, there is a square and you have minus of a square, so a square and a square gets cancelled. So that is in the denominator, and here it will become r minus a into r minus a into r plus a into r plus a. So let us do some arrangement. R minus a into r plus a is r square minus a square. So you have two pairs of r square minus a square here. So you can write the denominator as r square minus a square, the whole square. Okay, so let us write it. 4ar divided by r square minus a square, the whole square. So this is the final equation for electric field due to dipole at a point on the axial line. But we know the distance of separation between the dipoles are very small. So if we take a point somewhere in space which is very much greater than 2a, that means if r is very much larger than a square will be again very much small. So you can neglect the value of a square and you can rewrite the equation, simplified equation as q divided by 4 pi epsilon 0 4ar divided by r raised to 4. So here one r is there and here one r raised to 4 is there. You can cancel them and you can simplify the equation as q divided by 4 pi epsilon 0 4 a r will be cancelled, so it will be r cube. So now we are doing some rearrangement. 1 by 4 pi epsilon 0, because the value of 1 by 4 pi epsilon 0 is very much known to us, so let us write it alone. uh, 4 times qa divided by r cube. But we know the fact that 2aq is the dipole moment. So you can write this factor as 2 times 2aq. So it will be 2 times the dipole moment p. Okay, so let us rewrite the equation once again. It will be the electric field E is equal to 1 by 4 pi epsilon 0 2p divided by r cube. So you can consider this equation as the final equation for the electric field due to a dipole on the axial point.